Hello, today I'm looking at M3 International A-Level January 2015. This is question 7. So I have a particle P of mass m is attached to one end of a light elastic string of natural length a and modulus of elasticity lambda. The other end of the string is attached to a fixed point A on a smooth plane which is inclined at 30 degrees to the horizontal. The string lies along a line of greatest slope of the plane. The particle rests in equilibrium at point B, where B is lower than A, and AB is equal to 6/5 little a, and show that lambda is this. So this is for 4 marks. So the very first thing that I'll do is draw quite a sloped slope, reasonably big. And I have this point A, which the string is attached to. And then the string will lie down the slope, and I have the natural length, which they said was A, and then I'm not drawing this to scale. Then I've got this A over 5, because I did this value, take away the natural length to give me this extension here. And then when it's here, the forces acting on it are going to be the weight, which will be, if the mass is m, the weight is mg. The angle of the slope they said was 30. So I'll then draw in the perpendicular to the slope here. This angle is also 30. And the force up the slope is going to be the tension, which will equal lambda multiplied by the extension divided by the natural length, and the natural length was A. So in fact these A's are going to cancel, and we've just got a force of lambda over 5 acting up the slope. Now, in addition to this, we will have a force perpendicular to the slope of the normal contact force, but because the plane is smooth, then I won't need that to work out anything to do with friction, because there is no friction, or the friction is negligible. And so I can just ignore that. And so really I'm only concerned with what's happening in this direction. Now they said it was in equilibrium, so there's no acceleration. And so I can now use Newton's second law down the slope to say forces down the slope equal forces up the slope. So I've got mg multiplied by sine 30 equals the force up the slope, which was lambda over 5, because I saw that these two values cancelled out. So sine of 30 is a half, so I end up with mg over 2, and then multiplying both sides by 5, I end up with lambda as required. Okay, so that is for the first 4 marks. Then I'm told that the particle is now pulled down the line of greatest slope to point C. So this was point B here. And so when it's pulled beyond that, then it will be extended even more, and then it's released from rest. Show that P moves with simple harmonic motion of this period. Okay, so now basically what I will have is A's here, B's here. So I've got the natural length, that A over 5, that took me down to this position B. And then on top of that, I know that C is here, where A is over 5. And I know it's going to move with simple harmonic motion between these 2 points. These two should actually be the same length, so this is a drawing which is not to scale. However, if I am trying to show that it moves with simple harmonic motion, I need to not use this value, but I need to just displace the particle x away from B and see what would happen in this general position. At that point, the acceleration will be down the slope x double dot, and so I will do the forces down the slope minus the forces up the slope equals mass times acceleration. So doing Newton's second law down the slope, just as before, I have the weight multiplied by sine of 30, which is a half, and I end up with, going up the slope, lambda, which they told me was this, 5 over 2 mg. 5 over 2 mg, that's lambda, multiplied by the extension divided by the natural length. Well, the natural length I know is L, and this time the extension is A over 5 plus X. So be careful not to use A over 5 plus A over 5. We just need a general position X here in order to end up with the simple harmonic motion equation. Okay, so I've got forces down the slope minus the tension up the slope equals the mass, which was m, multiplied by the acceleration x double dot. Okay, so you see you've got m's everywhere, so they will cancel. And x double dot is always already the subject, so that's good. So here I end up with g over 2. Here the 5's cancel, the a's cancel, so I end up with g over 2. And here I end up with minus 5g over 2ax. So these two bits leave you with 0. So I'm just left with x double dot is minus 5g over 2ax. And so this is simple harmonic motion because you end up with this minus omega squared x equals x double dot form, and omega will be this thing square rooted. So 5g over 2a all square rooted. Okay, so that part of the question is B, worth 6 marks. Then I'm asked to find, in terms of g, the greatest magnitude of the acceleration while the string is taut. So because I know now that we've got simple harmonic motion, x double dot max, so the maximum acceleration, will be omega squared 5g over 2a, so without the square root, multiplied by the maximum that x can be. And if you remember, this was pulled down by a value of a over 5. Okay, so you might notice that I've just fluffed over this and just missed out the negative sign. So I've done omega squared multiplied by x, but I've just missed out the negative sign. That is because x is measured in this direction. So when we're talking about it being here, the acceleration will be actually up the slope, because the string will try to return to the equilibrium position. So therefore you will end up with a negative acceleration, because as we said, acceleration is measured down the slope. Instead, if I were to put this value in of negative a over 5, the two negatives would cancel, and then you get a positive acceleration. Okay, so here they ask for the magnitude of the acceleration, so I need to make it positive in any case. Let's see what that will end up to be. The a's will cancel, the 5's will cancel, and I just get g over 2 as the maximum acceleration. And that is part C, worth 2 marks. Finally, it says the midpoint of BC is D, and the string becomes slack for the first time at point E. So B was here, C was here, so D is exactly in the middle, midpoint. And the string will become slack at for the first time at E. Find in terms of A and G the time taken by P to travel directly from D to E. Okay, so where will the string become slack? Well, the string will become slack when we reach this point here, because the natural length of the string was A. So we need the time it takes to get from here to here. Now, if I'm looking for the time taken, I can use x is a sine omega t, and I'm pretending that the motion starts from here, because the time it takes to go from there to there and the time it takes to go plus the time it takes to go from there to there will equal the time it takes to go from there to there. So I can use this formula. Now, if I just rearrange this, this means that I'm going to get x over a will be sine omega t. So therefore t will be 1 over omega inverse sine of x over a, rearranging this. So then I can use that to get the 2 times that I need. So at D, x, and here we're using x measured from the equilibrium position. So it's going to be half of a over 5, which is a over 10. And at E, x is, I could write negative a over 5, but that's going to be the same as if I put it over here. So I can use a over 5, minus a over 5, or a over 5. But in order to get a positive value, I'm going to put a over 5. Okay, which in fact is the amplitude. Okay, so what will happen then? So for D, then I'm going to end up with 1 over, so the time at D, so from B to D, is going to be, using this formula, 1 over omega. So omega was this, so 1 over that is root 2a over 5g times by inverse sine of x over a. So the x was this, so I'm doing x divided by a, where a is the amplitude, and the amplitude was a over 5. So divided by a over 5 is like multiplying by the reciprocal. And so here this cancels, that cancels, and gives me a half. Then the time that it takes to get from B to E will be root 2a over 5g inverse sine, and this time I get the amplitude divided by the amplitude, so I'll just get 1. So then the total time, therefore, will be root 2a over 5g, the multiplied by inverse sine of a half, which will be 30 degrees, but remember we're working in radians here, so I get pi over 6, and inverse sine of 1 is 90 degrees, but remember we're working in radians, so that is pi over 2. So the total time, I get a 6th plus a half of pi, so pi over 6 plus pi over 2 gives me 2 pi over 3. So I end up with 2 pi over 3 multiplied by this thing, root 2a over 5g. Okay, so that final bit of the question was worth 4 marks. So you have 4, 6, 2 and 4, so a total of 16 marks in that question. Okay, I hope you found that solution helpful. You could like if you liked it, and good luck with your studies. Bye-bye.